A Harvard scientist has shattered the silence with a warning that could rewrite humanity's story in the stars. 3I/ATLAS, the enigmatic interstellar wanderer streaking through our solar system, is releasing metallic alloys that defy every known law of earthly chemistry. These aren't just odd traces of cosmic dust. They're compounds that shouldn't exist naturally, forged in ways that scream of something far beyond our wildest imaginations. Picture this: a ghostly visitor from the void between stars, hurtling at over 130,000 miles per hour, shedding vapors of pure nickel with no iron in sight, a ratio so impossible it has experts whispering about engineered origins. Avi Loeb, the Harvard astrophysicist who's never shied away from the extraordinary, is raising the alarm, urging the world to confront the possibility that this isn't a random rock, but a relic from an intelligence we can't yet comprehend. The implications? They could dismantle our understanding of the universe, forcing us to question if we're truly alone or if the cosmos has been hiding visitors all along. Buckle in, because the truth unfolding right now isn't just astonishing. It's the kind of revelation that ignites the soul and chills the spine. It all began on a crisp night in the Chilean Andes, where the ATLAS telescope, designed to hunt for doomsday asteroids, picked up a faint streak slicing through the constellations. July 1st, 2025, marked the moment everything changed. This wasn't your typical comet lazily orbiting the sun. No, 3I/ATLAS exploded into view like a bullet from the infinite dark, its trajectory a screaming declaration of otherworldly birth. Astronomers scrambled, cross-checking data from observatories worldwide, and the math painted a picture straight out of a fever dream. With an eccentricity of 6.141, this object's path was hyperbolic, unbound by the sun's gravity, meaning it had come from beyond our stellar neighborhood and would never return. Clocking in at 58 kilometers per second relative to the sun, it outpaced anything born in our system, a speed that whispered of origins near the galactic core, perhaps ejected from a distant star's violent death throes billions of years ago. As the data poured in, the excitement turned to bewilderment. By mid-July, images from Hubble and ground-based scopes revealed 3I/ATLAS as a colossal beast, estimates pegging it at over a kilometer wide, far larger than its predecessors, Oumuamua and Borisov. Imagine standing on a mountaintop, gazing at the night sky, when suddenly a speck ignites, growing brighter as it barrels inward. It's coma, a hazy envelope of gas and dust, blooming like a spectral flower under the sun's intensifying glare. But this wasn't a gentle bloom. It was a frantic unraveling, the object shedding material at an alarming rate as it plunged toward perihelion, its closest solar approach on October 29, 2025. Scientists watched in real time as it crossed Jupiter's orbit, the giant planet's gravity barely nudging its relentless course. This visitor wasn't here to stay. It was a one-way ticket through our cosmic backyard, destined to vanish back into the interstellar abyss. The real shock hit when the spectrographs fired up. At the Very Large Telescope in Chile, astronomers captured the light splitting into rainbows of revelation, and what they saw defied decades of comet science. Strong emission lines of nickel vapor leaped out, atomized metal streaming off at 4.6 grams per second by late August. Nickel, that hardy element forged in stellar furnaces, wasn't the surprise. Comets often carry traces of metals. No, the gut punch was the absence. Zero iron. In every meteorite fragment that has ever kissed Earth's atmosphere, in every comet tail we've dissected, nickel and iron dance together. Inseparable twins born from the same explosive stellar wombs. Their ratio? Typically 1:15 in solar system bodies. Here it was infinite, nickel alone, pure and unadulterated, like a refined alloy from a high-tech foundry, not the messy chaos of nature. Feel the weight of that for a moment. Iron and nickel are cosmic siblings, clumped in minerals like kamacite and taenite, released side by side when ice sublimates near a star. Separating them in a lab requires precision smelting, electromagnetic fields, or chemical wizardry. In space, it's unprecedented. a chemical fingerprint that doesn't match any playbook. Avi Loeb, poring over the spectra in his Harvard office, couldn't ignore it. This isn't natural, he declared in interviews that sent shockwaves through the scientific community. The universe doesn't purify metals like this without a reason, or perhaps without intent. His words hung heavy, evoking images of ancient alchemists transmuting base metals into gold, but on a galactic scale. Could 3I/ATLAS be the remnant of a supernova's asymmetric blast, where jets of nickel escaped while iron lagged behind? Or was it something more profound, a deliberate construct designed to stand out, to signal? The mystery deepened with the James Webb Space Telescope's gaze. In infrared sessions spanning July and August 2025, JWST peeled back the layers of 3I/ATLAS's volatile shroud, revealing a dominance of carbon dioxide that shattered records. An 8-to-1 ratio of CO2 to water vapor, 129 kilograms per second of carbon dioxide versus a mere 6.6 of water. Typical comets? A paltry 4% CO2. This was a carbonated frenzy, the object belching gas like a pressurized canister popped in the vacuum. Carbon monoxide and carbonyl sulfide joined the mix, but nothing rivaled the CO2 spike. Visualize it, a colossal icy body awakening from eons of cryogenic slumber, its surface cracking under solar heat, releasing plumes that twist into ethereal tails, glowing in the infrared like a phantom aurora. But why so much CO2? Cosmic ray bombardment during its billion-year trek could have built exotic ices, or perhaps it formed in a star system rich in carbon worlds. Yet, combined with the nickel anomaly, it painted a portrait of extremity, a chemistry so skewed it begged for explanation. Loeb didn't hesitate to connect the dots. Drawing from his controversial stance on Oumuamua, the cigar-shaped enigma of 2017 that accelerated without visible outgassing, he argued that 3I/ATLAS's traits mirrored artificial design. Nature abhors such purity, he posited, his voice carrying the urgency of a prophet in the wilderness. These alloys suggest a technological origin, perhaps a probe or fragment from an extraterrestrial civilization. The words ignited debates, forums buzzing with speculation, hearts racing at the thought of alien handiwork brushing our doorstep. Imagine the thrill, humanity, for millennia staring at the stars in wonder, now facing evidence that those stars stare back, sending emissaries cloaked in metal and ice. But let's step back into history to grasp the gravity. Long before telescopes pierced the veil, ancient skies delivered metallic harbingers. In Egypt's Giza cemetery, 5,000-year-old iron beads gleam with 30% nickel, impossible for earthly ores, a celestial gift hammered into tubes of power. King Tutankhamun's dagger, its blade etched with Wittmann-Stetten patterns unique to slow-cooling space iron, held 11% nickel, a relic more precious than gold. These artifacts weren't mere tools. They were talismans from the heavens, symbols of divine might. Across Bronze Age cultures, from Syria to China, sky-fallen iron bore the same high nickel stamp, forging legends of gods hurling thunderbolts of metal. The ancients didn't know of supernovae or asteroid belts, but they felt the otherworldliness in their hands, the weight of materials born in the stellar cataclysms. Now fast forward to 3I/ATLAS, and the echo is deafening. If ancient meteorites carried alloys that awed pharaohs, what does this interstellar giant bear? Loeb's warning isn't hyperbole, it's rooted in patterns. Oumuamua's odd shape and acceleration hinted at solar sails. Borisov's high carbon monoxide suggested distant formation. But 3I/ATLAS, it's a symphony of anomalies. Metallic purity, volatile excess, and a trajectory that skims Venus, Mars, and Jupiter with improbable precision. A 0.005% chance by random odds, as Loeb calculated. Picture the object as a silent scout, threading planetary orbits like a needle through fabric, surveying our world from afar. The emotional pull is inescapable. Wonder surges as we contemplate a universe teeming with secrets. Fear creeps in at the unknown's edge, and curiosity burns like solar fire. Is this nature's masterpiece? a kilonova's fallout where neutron stars collided, birthing nickel-rich debris. Models of GW170817, the 2017 merger, show such possibilities, strontium and heavy elements flung in chaotic ratios. Or asymmetric supernovae like W49b, where X-ray maps reveal nickel jets separated from iron cores. These natural forges could explain it, stretching our knowledge to extremes. Yet the heart races at the alternative. What if these alloys are engineered, isotopes arranged like code in a cosmic QR? Earthly science uses isotopic signatures for forensics. Imagine an advanced society embedding messages in matter, durable against time's erosion. 3I/ATLAS could be a Voyager-like record, not grooves on gold, but anomalies in atoms, waiting for us to decode. As observations mount, high rise on Mars, reconnaissance orbiter potentially imaging it during its October 3rd flyby, the tension builds. This isn't abstract. It's happening now, a messenger from the stars challenging us to look deeper. The universe, once a vast emptiness, feels alive, pregnant with possibility. And as 3I/ATLAS hurtles onward, it leaves us pondering. Are we witnesses to nature's wildest art, or the first glimpse of a greater conversation? The answers could upend reality itself, drawing us into a narrative where humanity steps from isolation into the galactic fold. The mystery of 3I/ATLAS deepens as it streaks closer to the sun, its secrets unraveling under the relentless scrutiny of humanity's most powerful instruments. Imagine the scene, a colossal, icy behemoth from the interstellar void, glowing faintly in the cosmic night, its surface fracturing like ancient glass as it nears the star's fiery embrace. Every telescope on Earth and in orbit is locked onto it, capturing data that twists the knife of curiosity deeper into our collective psyche. The nickel-heavy, iron-free vapors streaming from its coma are no longer just an anomaly, they're a challenge to everything we thought we knew about the universe's chemistry. The carbon dioxide dominance, 8 times higher than water, paints a picture of an object that doesn't just bend the rules, it obliterates them. And then there's the trajectory, a path so improbably precise it feels like a cosmic arrow aimed at the heart of our solar system. This isn't just a visitor passing through, it's a puzzle demanding to be solved. A whisper from the stars that could either be nature's strangest creation or a deliberate signal from a mind we can't yet fathom. Let's dive into the chemistry, because the numbers are screaming for attention. By September 2025, the Very Large Telescope in Chile had clocked 3I/ATLAS's nickel output at a steady 4.6 grams per second, a metallic vapor trail glowing in the spectra like a neon sign in the void. But the absence of iron isn't just a quirk, it's a cosmic scandal. In our solar system, iron and nickel are forged in lockstep, born in the hearts of dying stars where temperatures hit millions of degrees and neutrons slam into atomic nuclei. Supernovae, the explosive deaths of massive stars, churn out these metals in predictable ratios, typically 15 parts iron to 1 part nickel. Meteorites crashing to Earth, from the Sahara to Antarctica, carry this signature, their crystalline structures, Widmanstätten patterns, etched with the slow cooling of space over millions of years. But 3I/ATLAS, it's as if the universe took an industrial refinery to the cosmos, stripping iron away and leaving pure nickel to vaporize in its wake. Picture a blacksmith forging a blade, but instead of mixing alloys, they craft something impossibly pure, defying the chaos of natural creation. Avi Loeb, the Harvard firebrand, leans into this anomaly with the intensity of a detective chasing a lead. His calculations, drawn from decades of studying stellar nucleosynthesis, suggest that no known natural process easily explains this. Supernovae, even the asymmetric ones like W49b, where nickel jets out in plumes while iron clumps in the core, struggle to produce such extreme purity. Kilonovae, cataclysmic collisions of neutron stars, offer a closer fit. The 2017 GW170817 event, observed by LIGO and Virgo, showed strontium and other heavy elements forming in a neutron blitz, with nickel potentially dominating in certain debris patches. But even here, the models stretch thin. The nickel-to-iron ratio in 3I/ATLAS is so skewed it demands a near-miraculous alignment of conditions. A precise pocket of kilonova ejecta, cooling over eons, drifting across the galaxy to reach us intact. It's possible, but it's like winning the cosmic lottery twice in a row. Then comes the carbon dioxide enigma, a volatile signature that's rewriting comet science. The James Webb Space Telescope, its infrared eyes piercing the haze, measured a CO2 to water ratio of 8 to 1, 129 kilograms of carbon dioxide per second, dwarfing a mere 6.6 kilograms of water vapor. Imagine this, a frozen traveler, its surface bubbling like a soda bottle shaken for a billion years, releasing plumes that glow in eerie infrared hues. In our solar system, comets like Hale-Bopp or Hyakutake hover around 4% CO2. Their tail's a mix of water, dust, and trace gases. 3I/ATLAS, by contrast, is a carbonated juggernaut, its chemistry suggesting a birthplace wildly different from our own. Some hypothesize it formed in a carbon-rich star system, perhaps orbiting a star with planets of diamond and graphite. Others point to cosmic ray bombardment, where high-energy particles hammered its icy shell during its interstellar voyage, building up exotic CO2 layers. But the sheer scale of the spike, paired with the nickel anomaly, feels like a cosmic double-take, a composition so extreme it's hard to chalk up to chance. The trajectory adds fuel to the fire. By early September, astronomers had mapped 3I/ATLAS's path with pinpoint precision, revealing a course that threads the needle of our solar system. It skims Venus at 0.3 astronomical units, brushes Mars at 0.2, and swings past Jupiter at 1.1, a cosmic slalom that aligns with 3 planets in a single pass. Loeb's team crunched the numbers, and the odds of this happening randomly are a staggering 0.005%, like tossing a dart from a mile away and hitting a bullseye the size of a pinhead. Picture the object hurtling through space, its path a flat, retrograde arc, tilted just 5 degrees from the solar plane, moving backward against the planet's flow. It's as if it's surveying our system, choosing a route that maximizes close encounters while dodging easy detection, reaching perihelion on the sun's far side, where Earth's telescopes strain to see. The emotional weight hits hard, awe at the precision, unease at the implications. Is this blind luck, or does it feel intentional, like a probe charting a course to observe without being observed? This isn't the first time we've faced such questions. Cast your mind back to 2017, when Oumuamua burst onto the scene, a cigar-shaped enigma accelerating without a visible tail. Its light curve suggested a tumbling object, perhaps 10 times longer than wide, defying every asteroid or comet model. No outgassing, no coma, just a silent sprint through our system, gaining speed as if pushed by an unseen force. Loeb's solar sail hypothesis sparked a firestorm, suggesting an artificial origin, a thin sheet riding starlight's pressure. Critics countered with exotic ices or fractal dust, but no explanation fully fit. Oumuamua left before we could probe deeper, its mystery a scar on the scientific psyche. Then came Borisov in 2019, a more normal interstellar comet, yet still packing surprises with its high carbon monoxide. Now 3I/ATLAS, with its metallic and volatile anomalies, feels like the third act in a cosmic trilogy, each visitor pushing the boundaries of what we believe possible. The historical echoes are haunting. Ancient cultures revered sky-fallen metals as divine, crafting them into symbols of power. The Gerza beads, Tutankhamun's dagger, their high nickel content marked them as otherworldly, gifts from a realm beyond human reach. Today we're no less awestruck, but our tools are sharper. Every spectrum, every orbital calculation pulls us closer to the truth, or further into the unknown. If 3I/ATLAS is a natural object, it points to cosmic forges we've barely begun to understand, where kilonovae or lopsided supernovae sculpt alloys in ways Earth never could. But if it's engineered, The implications are seismic. Imagine a civilization embedding a message in the very atoms of this object. Isotopes arranged like a barcode, durable across billions of years. On Earth, we've done this on a smaller scale. Voyager's golden record, etched with music and math, a snapshot of humanity for the stars. Could 3I/ATLAS be another culture's record? Its chemistry a deliberate signal? The heart races at the thought. Picture scientists huddled in observatories, their screens glowing with spectral lines, each data point a potential clue to a galactic conversation. The fear is real. What if we're not ready for the answer? But the curiosity is stronger, a primal urge to decode the unknown. As 3I/ATLAS approaches its October 29th perihelion, the stakes climb higher. The Mars Reconnaissance Orbiter's high-rise camera, poised for a possible snapshot during its close flyby, could reveal surface details, craters, fissures, or something stranger. Every new observation is a heartbeat, a chance to tip the scales toward nature or intent. The universe feels alive, not a cold void, but a stage where matter itself might carry meaning, where humanity stands on the cusp of a discovery that could redefine our place among the stars.